Hey, welcome back. This is section 11.6 on the radioactive decay series. So our goals in this section are to be able to describe the concept of a radioactive decay series. So a radioactive decay series is a series of radioactive decay processes or steps, beginning with a long-lived radionuclide and eventually ending with a stable nuclide of a lower atomic number. So you start with your unstable parent nuclide, shown here, and it's going to undergo radioactive decay, right? Each of these gray boxes in teeny tiny font says radioactive decay, undergoes radioactive decay and produces a daughter nuclide. Well, if the daughter nuclide isn't stable, it's still radioactive, it's going to undergo radioactive decay itself and produce an even slightly more stable daughter nuclide. And then if that one's still not stable, it'll undergo radioactive decay again to produce, again, a new daughter nuclide. And as long as the daughter nuclides produced are unstable, they're going to keep undergoing radioactive decay until eventually they reach a final stable daughter nuclide product, and the process will stop. So this is the decay series for uranium-238. This one's been mapped out because uranium, again, is one of those naturally occurring radionuclides that is found in kind of greater abundance than many of the other radionuclides. So it's one that's been extensively studied, as well as extensively used in research, as well as for commercial purposes. So if we check this out, right, you start at the top. We start with uranium-238. Its half-life is 4.5 times 10 to the 9th years, so 4.5 billion years. So every 4.5 billion years, half of the uranium-238 is going to decay, undergo alpha decay, to turn into thorium-234. Then the half-life of thorium-234 is 24.5 days. After 24.5 days, half of the thorium-234 will undergo beta decay to become proactinium-234. That half-life is only 1.14 minutes. So very rapidly, the proactinium undergoes alpha decay to become uranium-234. Kind of weird, right? We started with uranium-238, underwent some decay series, and now we're back to uranium. It's because with an alpha particle, you're ejecting 2 protons and 2 neutrons, but then with these beta decays, your charge numbers, again, increasing by 1 because you're ejecting a negatively charged particle, which is how you end up back at uranium. Then uranium has a long half-life. 234's half-life is 2.33 times 10 to the 5th years, so 233,000 years. Not as long as uranium-238, but still good amount of time. It'll undergo alpha decay, turn into thorium-230, and so forth and so forth. So it keeps going until eventually, way down here, you reach lead-206, which is stable. And so once you reach the stable final daughter nuclide, the process stops and you have a stable element that won't undergo radioactive decay anymore. What's really important to point out on the decay series for uranium is that right here in the decay series, we produce radon-222. And radon is a gas. All these other things are solids. Most of this is happening in the Earth's crust. We don't even know what's going on. There's always this like background little bit of radiation being produced from metals in the Earth's crust that can undergo radioactive decay. But in uranium's decay series, because at this point it turns into radon, radon's a gas, so it doesn't necessarily stay trapped in the Earth's crust like all of these other minerals and metals. And so this is where in some areas of the world, if there's a lot of uranium ore just naturally found in the soil, as that uranium ore undergoes decay, some people have to occasionally check their basements for radon poisoning, because if they live in an area where there's a lot of uranium ore in the soil naturally found, as that uranium ore decays, it's going to produce radon gas. And because radon-222 is a gas, it's going to escape from the soil. And then it could be breathed in, or people could be exposed to this radioactive gas. Right? It sounds like terrifying. And then that can cause health problems, because if you ingest radon-222, it's going to undergo alpha decay. And when alpha decay happens inside a person's body, it's a type of ionizing radiation, so it can cause some, serious health problems. So this is why in some parts of the world, there's like radon detectors in basements, or buildings are built underground. They'll have radon detectors installed to make sure that there's not excessive amounts of radon gas being produced due to this natural uranium decay series. We'll talk more about that when we talk about natural sources of radiation. Okay, so our next section is going to be on detection of radiation, the different ways that we can detect and quantify and measure it. Section 11.7. I'll see you then. Thanks.